Today we will discuss about fundamental theorem arithmetic and its application to prove root 2, root 3 like this, the terms as irrational numbers. Fundamental theorem of arithmetic. The proof is not necessary. Let P be a prime number if P divides a square, then P also divides a. What is a? Where a is a positive integer. I repeat, let P be a prime number if P divides a square, then P also divides a, where a is a positive integer. You have to remember this one. That is, P square is, that is a m is equal to P square, means P square divides am. So an is equal to P. You can say P square is equal to am, P is equal to an, where m and n are the real numbers. Okay. Now we are going to discuss about the root terms. That means root 2, root 3, root 5 like this are irrational number in contradiction way. We will discuss a general expression, then after we will apply that general expression into specific applications, specific questions. One is, prove that root x is an irrational number. Root x is an irrational number. What is x? X may be 2, 3, 5, 7 like this. Okay. See, this is general expression. There is no hard and task rule. You have to know this. But if you know how to prove root x is an irrational number, then for root 2, root 3 it becomes very easy, because simple you have to replace x by 2. For this, let root x is a rational number. As you know, if root x is a rational number, then root x is equal to r by s. What are r and s? Where r and s are prime factors, s is not equal to 0. Then root x is equal to a by b, or you can say p by q. Root x is equal to p by q, where p and q are integers, and q is not equal to 0. In short, you can say p and q are co-primes. P and q are co-primes. Here, root x is rational means if you express, the rationals are expressed in the form of p by q, where you cannot further cancel. That means p and q are the co-primes. But here r and s are the factors. That's why I've written. Or directly you can write this. You can also omit this one. Root x is equal to r by s. Okay. So root x is equal to p by q, where p and q are integers. Q is not equal to 0, or you can say p and q are the co-primes. Now square in both the sides. X is equal to p square upon q square. Squaring on both the sides implies by cross multiplication p square is equal to x into q square. X into q square, that means p square, I can write x divides p square, implies x also divides p by fundamental theorem. Fundamental theorem that we have just discussed. Okay. Now suppose this is your 1. Assume that p is equal to x m, then p square is equal to x square m square, and you know p square equal to x q square, p square equal to x square m square. You can equate these two terms. Therefore x square m square is equal to x q square, implies q square is equal to x m square, implies x divides q square, so x also divides q. But we have assumed p and q are co-primes. Here x divides p, x divides q, so x is the factor of p and q. If x is the factor, then implies p and q are not co-primes because x is the factor. Hence root x is not rational. Thus root x is irrational. At the beginning you assume, let, we are proving this by contradiction method. Question is root x is an irrational number. We assume root x is a rational number. For rationality you can write root x is equal to p by q, where p and q are the integers, q is not equal to 0, and p and q are the co-primes. This is very important, co-primes. Now you square on both the sides by cross multiplication. You got p square equal to x q square. Here x divides p square because p square is a multiple of x, so x also divides p by fundamental theorem. Similarly, you assume p as xm, where p square equal to x square m square. Now you can equate p square equal to x q square and p square equal to x square m square. What you will get? X square m square equal to x q square. So q square equal to x m square. X divides q square, x divides q. This is also by fundamental theorem. Fundamental theorem. So x is the factor of p and q, but you assume p and q are the co-primes, but here x is the factor of both p and q, so p and q are not co-primes. So root x is not rational, so root x is irrational. See, you can apply this general expression to prove root 5 is irrational. Whenever x is written in the above expression, simply replace x by root 5. Okay, let you check whether we are getting the proper solution or not. We have assumed root 5, root x is equal to p by q. So root 5, let root 5 is a rational number. Rational number. If rational, then root 5 is equal to p by q. We have discussed root x is equal to p by q. So root 5 equal to p by q as it is rational. And what are p and q? P and q are integers where q is not equal to 0, and we can write, and one more, p and q are co-primes. Now square on both the sides. 5 is equal to p square by q square. By cross multiplication you get p square equal to 5 square, implies p square is 5 divides p square, implies 5 divides p by fundamental theorem. You have to write in the bracket, let p is equal to 5m square, p square equal to 25m square, or you can write 5 square m square. Compare p square equal to 5q square, p square equal to 5 square m square. So what will you get? 5q square equal to 5 square m square, implies q square equal to 5 m square. So 5 divides q square, implies 5 divides q by fundamental theorem. So p and q are not co-prime. Why? Because 5 divides q, 5 divides p. So 5 is the common factor of p and q. So p and q are not co-primes. Hence root 5 is not rational. So root 5 is irrational. Clear? Similarly, one more general expression, that is a root b, or you can write prove that a root x is an irrational number where x is 2, 3, 5 and h any positive number, any positive integer. Okay, x is 2, 3, 5 like this, a is any positive integer. See, this is general expression. Just for our reasons, we will discuss about this, about a root x is an irrational number. Further, you can replace a by 2, 3, 4, 5, 1, anything, and x by 2, 3, 5 like this. We will get the questions like this: 2 root 5, 3 roots 2, like this. You will get the questions to prove irrational numbers. For this, we are going to prove a root x is an irrational number. Let, same thing, contradict way, let a root x is rational. A root x is rational. If it is rational, then you can write a root x is equal to p by q, where q is not equal to 0, p and q are co-prime positive integers, or co-prime integers you can write. ठीक है. Next, square on both the sides. A square x is equal to p square by q square, implies p square is equal to a square x into q square by cross multiplication. So you can write p square is equal to do one thing, implies x is equal to p square by a q square. Okay, in this way you can prove that there is one shortcut. Okay, what is that? If a root x is equal to p by q, then you can write root x is equal to p by a q, where p and aq are integers. So p by aq is rational and root x is irrational. So a root x is not irrational. Hence, root x is rational. Right? For example, prove that 2 root 3 or any questions from your book. Suppose question is okay, 7 root 3 is irrational. Suppose you are going to prove 7 root 3 is irrational. How can you prove that 7 root 3 is irrational? Let 7 root 3 is rational. So 7 root 3 can be written in the form of p by q, where q is not equal to 0, p and q are integers, and p and q are co-primes. And q are co-primes. Okay. Now, what is root 3? Root 3 is p by 7q. Here, p upon 7q is rational, but root 3 is irrational, that you know. Therefore, rational never equal with irrational. Therefore, 7 root 3 is not rational. Hence, 7 root 3 is irrational. Okay? Clear? Another form, that is a minus root x is irrational. It may be plus or minus, same expression, simple change of minus into plus. It's general form. What are x? Remember, x is two non-negative terms. Okay, 2, 3, 5, that's same, clearly writing what is x. X is 2, 3, 5 and a is any integers. Okay, integer. Let a minus root x is rational. If rational, then you can express it in the form p by q, where q is not equal to 0, p and q are integers, and p and q are co-primes. So implies a minus p by q is equal to root x. Clear? P by q goes to left side and minus root x will go to right side. So a minus p by q is equal to root x. Take LCM q, a q minus p is equal to root x, implies root x is equal to a q minus p by q. Clear? Here root x is irrational, whereas aq minus p by q is rational. So it contradicts our assumption that a minus root x is rational, because irrational equal to rational, which is not possible. Therefore a minus root x is not rational. So a minus root x is irrational. Okay. Now example, a minus root x have taken. Let it be one question, 5 plus root 3 is irrational. We are going to prove irrational. Remember, instead of minus you have to write plus. Solution. However, 5 plus root 3 is rational, implies 5 plus root 3 is equal to p by q. You have to write q is not equal to 0. P and q are integers. P and q are co-primes. And now root 3 is equal to p by q minus 5. Take LCM. Root 3 is equal to p minus 5q. Here root 3 is rational, but p minus 5q by q is irrational. One is rational, another is irrational. Never equal. Rational is never equal with irrational. Therefore 5 plus root 3 is not rational. Hence 5 plus root 3 is irrational. Okay, like this you can prove the all questions of the exercise 1.3. of your NCERT book. Go through the exercise and try to solve it. Simple. I repeat this expression again. A minus root x is rational. Then you may also write a plus root x. Simple. Instead of minus, write plus. Very easily you can prove these things. Thank you.